Welcome. This is a webinar sponsored by ITS Canada's Advanced Public Transit Systems Technical Committee. Welcome all. I'm Brendan Hemley. I'm the chair of the APTS Technical Committee. And the APTS committee is one of 5 technical committees at ITS Canada and focuses specifically on transit ITS activities and developments and issues of concern and interest. Before we start, we have an interesting webinar today that I'll talk about in just a second, but just to mention, if you're interested in the APTS, I have a list of friends and there's an official list of committee members for organizations that are part of ITS Canada. And I also just want to mention that ITS Canada is having its virtual conference on June 21st and 22nd. So keep tuned for that. We're fortunate today to have a presentation first by Amr Shalabi, who is the director of the Transit Analytics Lab, TAL, that was launched last year. It is part of the University of Toronto Transit Research Institute, UTRI, and I also actually serve as a senior advisor to TAL. Amr will provide a overview of some of the activities that TAL has launched to support transit ITS, and specifically analytics and the use of data. And then afterwards, we'll have one of the outcomes of research undertaken by TAL by Omar Kabani, who's currently was a postdoc at U of T and is now working for mobilitydata.org, which is a forum for looking at improving the efficiency and use of standards such as GTFS and GBFS, the general bike specification. So with that, I will share my screen with Amr and have him take it away. Mute, make.
Okay.
Oh, your screen's already on.
Yeah.
Sorry. Okay, go ahead, Amr.
Okay, well, thank you very much, Brendan. Let me actually start by thanking ITS Canada and the APTS committee for inviting us to speak at this webinar. And thank you to everyone who registered in the webinar as well. Okay, so I'm going to spend a few minutes just to introduce Transit Analytics Lab, which, as Brendan mentioned, this was launched last year, in specifically May of 2020. And so I'm going to give a quick overview, and then I'm going to turn it over to Omar to speak up in more detail about one of the research projects that, in fact, is still underway. Okay, so there are a lot of technological trends disrupting the transit systems around the world, not to mention, of course, COVID, which is another trend that's disrupting our lives, and including public transit. But automation and connectivity is becoming slowly implemented. We see it implemented in various transit systems. Shared mobility, of course, is a very visible and very strong trend in many cities that have impacts on public transit. There's also electrification of transit fleets, bus fleets, and train operations, and obviously big data as well, which is really the focus of our endeavor here. So transit agencies are increasingly getting more data rich by implementing intelligent transportation systems for vehicle monitoring, for passenger counting, for fare collection. And over and above this, other streams of data are becoming available also for transit analysis and planning, such as data from mobile phone apps, sensors such as Wi-Fi, social media. And this is over and above the traditional data sets that transit agencies conventionally use for transit planning and management, including household travel surveys, passenger count surveys, rider satisfaction surveys, and so on and so forth. So, as I mentioned, transit agencies are becoming data rich, but they also suffer from the information poor syndrome, or the DRIP for short. So the process of really turning transit data and the rich transit data and diverse transit data into insights and also decisions requires a set of analytics or analytical methods, not only really for storage and visualization, but also methods from AI and machine learning and statistical analysis. And that's really was the impetus for TAL, which really the main motivation for TAL is to create this forum to bring researchers from across the University of Toronto. This is from engineering, from social sciences, from also fields focused on technology and AI and machine learning, as well as bring also practitioners from both the public sector and the private sector who are also working with diverse and data streams in really trying to improve the decision-making process for transit planning and also improving the transit user experience. So more specifically, TAL really aims for advancing and fostering innovations in data-driven decision-making using advanced analytics from using methods from machine learning, simulation, optimization, and data science. This is really a core objective and goal of TAL. Another one is obviously trying to train the students and train the next generation of transit professionals in transit analytics for decision making. And also TAL aims for transferring the knowledge both in the form of courses, but and also transferring technology that's developed in-house into the industry as well. And also work with others to perhaps advance the standards and specifications of data and methods. Our scope, we're a little bit ambitious. Our scope is to really cover all types of services and modes in public transit, both fixed route and demand responsive transit, and try to really cover also the entire or the full spectrum of decision-making domain, ranging from service planning all the way to corporate management, maintenance, and going as well as scheduling and real-time management. And in terms of analytics, we're also the typical classification now of descriptive, predictive, and prescriptive are also are within the scope of TAL. So I'm just going to walk you very quickly in just a few minutes about a sample of the research projects that we've been working on. One project which we are doing in collaboration with colleagues from U of T as well as from the US is to develop a dashboard for the transit center in the US for the visualization of fares, reliability, access scores, and equity scores in 7 US mega regions, including New York, San Francisco, Boston, Chicago, and so on. This is all utilizing open data streams, like we're using available data on the web. The other research project, which is really the focus of this webinar, so it's use of social media analytics for transit planning and management. So that's really the topic of the next talk. We've been also doing a lot of work on developing models to predict travel time and bunching incidents using different methods from machine learning. Also ridership forecasting and elasticity analysis using smart card data, using APC data, as well as in combination with also survey data to develop forecasting models for ridership and also compute elasticity. We've been also working quite a bit on disruption management. And specifically, we developed something called Dash Bus, which is a toolkit. It's a platform to help with decision making of deploying bus bridging plans. Whenever there's a subway incident, for example, in Toronto, where transit agency TTC would dispatch shuttle buses, there are a lot of decisions of how many buses and where those buses should come from. So we developed a data-driven toolkit to enable or to facilitate such decision making. Also, we work in the area of scheduling and driver absenteeism. So this is still new work that is currently underway, trying to develop multi-depot bus scheduling algorithms, as well as prediction models for driver absence. Another piece of work that's also underway is in the area of transfer time optimization, trying to synchronize timetables to minimize transfer times. And this is very important in sort of low frequency networks that are grid type. I also mentioned before DRT, demand responsive transit. There is a major project underway now that also try to develop a set of tools to plan and manage DRT services in combination with fixed route transit services. Also looking to the future of automation and connectivity, we're also working on projects that's trying to develop new concepts of service, of public transit service, like dynamic bus lanes and bus platooning and coordinated TSP along corridors. So, and those are all applications that are very data hungry, and they are all data driven. So those are, this is some work we're doing currently as well. And finally, management of crowd and transit flows at multimodal hubs and networks. This is also an ongoing project. We're using Union Station and the downtown subway network as our case study. So PAL doesn't work alone, works with a number of other partners within the university and outside the university. As Brandon mentioned, Brandon is actually a senior advisor to the center. We also have a number of centers within U of T. I'm not going to go over them all. But we also work with the industry as well. Much of our research is really done through partnership projects. We do them in partnership with industry partners from the public sector, from the private sector. And also we've been successful over the past few years to also attract funds from federal agencies and provincial agencies as well. This is the research team. We have about 8 professors now from U of T, and we have a large group of graduate students and postdocs who are working on different projects. Our plans is to continue working, really ramping up our research and development projects in partnership with the industry. Also, we are in the process of developing some courses focused on transit analytics, and this is for our graduate program at U of T as well as for professional training. Also to hold workshops and symposia. So last year we held the 6th International Transit Data Symposium, hosting about 250 participants from around the world. And then that was followed by another workshop that we organized in December, which was attended by about 100 people from Ontario mostly. So that's pretty much it. And I'm going to turn it over to Omar to give us more details about his project.
Thank you, Amr. Can you pass it, or just you can close and I can do it?
Okay, I'll see how.
Actually, I think I can do it directly.
Yeah, because I don't see anywhere that
There we go. Oh,
perfect.
Omar, you need to turn on your camera, and you're unmuted. That's good.
Coming up.
Perfect.
All right.
Don't see you. Oh, there you go. Great. Okay, I'll turn off my camera.
I believe my screen is
Yep.
shared.
It is.
All right, so I'll just get started. Hi, everyone. My name is Omar, and thanks for coming. This is a presentation called Using Data from Twitter to Improve Operations and Planning Public Transit. And the research team was myself, Dr. Shalabi, Dr. Jarabi, and Dr. Willem Kluppenhaber. And we were funded by Calgary Transit, QTRIC, and NSERC. So as a quick outline, we'll go over an introduction where we talk about the motivation of this work. Then we talk about social media for insights on rider satisfaction. Then we talk about IoT detection. And lastly, we talk about conclusions and future research. So as the introduction, the motivation for this research was that the current approaches to gauging rider satisfaction is very limited to the customer satisfaction surveys. And these are expensive, they give us a static data set, and they lack the temporal granularity. We also see that there's a lot of data on Twitter that we don't really use. There's a wealth of data there. And the third component is that there's many incidents that are not easy to detect by transit agencies. And these ones have a big impact on ride quality. The examples are damaged facilities, disruptive passengers, unsafe behavior, and violations to COVID-19 guidelines, amongst others. So in that spirit, the objectives of our research were twofold, more like onefold. We need to augment the capabilities of transit agencies to rapidly process feedback from riders. And by feedback, we mean satisfaction levels, and we mean incident reporting. So we split this into two main goals. The first is to gain insights on rider opinions through analyzing transit tweets and accounts. And the second is to facilitate the incident response by identifying tweets that describe transit incidents in real time. And we based this work on one of our partners, Calgary Transit, as a case study. Calgary Transit serves the 1.3 million citizens of Calgary using LRT and bus routes. And their account at Calgary Transit is very active in tweeting about disruptions, answering questions, and posting general content. So for the first component, which is using social media for insights on rider satisfaction, we like to use data from social media because it acts as a virtual focus group. It gives us raw, unfiltered content from customers. We get a lot of data about data. So we get metadata, which is like engagement information, timestamp data, location data, and so on. We also get access to content on other agencies. So we not just see our agency, but we also see the other agencies around us. So it's kind of a level playing field. And we can get metrics and insights from online campaigns. So there's a lot to process with online social media information. And the bulk of this component is opinion dynamics, which is how opinions develop and how they're shaped. And we used 4 kinds of analyses. The first of which is semantic, and which just understanding topics of what's going on. And then we applied sentiment with that. So these 2 components give us what opinions are. And then we combine that with temporal to understand how these opinions are changing with time. And lastly, we integrate social network analysis to understand not just what is being said, but who is saying what. And for that purpose, we built a web-based tool that has team management, customizable analyses, and reporting function. And we currently have an open beta ongoing for this tool. So how it works in a very high level, we extract tweets and we filter them. And by that, we mean we look at the timestamps to understand when they're being sent. We look at the words to understand the themes and topics of these tweets. And we look at the accounts themselves. So who do they follow, who follows them, how many followers they have, and all that stuff. So it's temporal, semantic, and social. Then we apply sentiment analysis on the tweets to understand the feelings of the riders. And lastly, we do social network analysis, where since we're working with Twitter, we get the accounts, we look at who they know and who they follow, so we can build one big social network and analyze it and quantify it using the attributes on the right side. And the lastly, we do reporting, which is generating nice dashboards like the one we see over here. So a bit more details on what we can do in this tool. So the tool has team functionality, which means we can allow each team its own unique scope. We can get access levels for different roles. We can create custom lexicons to define topics of tweets, and we can have unique developer keys for each team to extract Twitter content. And then we can start the analysis. So we select which agency we're going to target. We select the temporal details. So we want to look at these days only, at this time of the days, like tweets coming at these days, at these times, for example. Then we define the semantic parameters, which is how do we label tweets by topics, and lastly, the social parameters. Do we want to look at the entire social network of people talking about transit, or do we want a subset of influential accounts or certain communities? So there's a lot of parameters to go into the analysis. And then we allow some user input where to ensure better data quality, so we can see the top accounts and the top terms for these tweets that satisfy the filters we showed earlier. This allows for like quality control manually, and it gives us insights on high-level insights on who tweets the most about transit and what are the themes or like most discussed topics that appear in these conversations. And lastly, once the analysis is complete, we get a nice report. So on the left side, we can see the breakdown of topics. We also see the breakdown of sentiments under that. And in the middle, we can see a social network profile. So we see a nice power law fit for online social networks, which is what we expect. And then down there, down in the middle center, bottom center, we see the attributes of the network. And then in the bottom right, we see the breakdown of topics by breakdown of sentiment by topics. So this is what was discussed, a good snapshot of what was discussed in a certain time period about a transit agency. And we also did just a quick analysis for tweets for June, July, and August last year, mostly about COVID-19 tweets. And it's interesting to see how the number of tweets changes, how the network structure changes, and how the conversation changes. And we identified other use cases for this tool. So on top of just looking at what rider opinions look like, we can also assess the effects of service changes on rider satisfaction. We can also dig deeper and generate new rider experience indicators, such as number of negative tweets per day or per kilometer. We can conduct post-incident assessments and look back at days where we had disruptions and see what went wrong, what went right. And lastly, developing a service quality index to understand what riders value most based on their Twitter interactions. So this pretty much covers the first part of the presentation, which is just a tool that allows us to gauge what riders are talking about at an aggregate, at say a high level. And now the second part of the presentation is showing you what we can do with eyewitness tweet analysis. So our framework here is that we first need to detect transit tweets and what they look like. And the next component is to identify which ones of these tweets are eyewitness tweets. And what we mean by eyewitness tweets are tweets that are sent out by people reporting something happening in front of them. So they're saying like this tweet here on the right says, hi, something happening on my bus. Yeah, it's describing an ongoing incident. And the third component is to extract location information from this tweet. So we see here, this tweet mentions an exact bus route number and a bus ID. So how do we automate all this? These are just examples for information about what eyewitness tweet looks like. So for example, the top left tweet says, hey, there's a bunch of smashed glass here at McKinsey Town Terminal. They're describing what they're seeing in front of them right now. So it's like getting incident reports from these tweets. And to do this, we used artificial neural networks. So we developed 2 neural networks, and we used over 70,000 or like around 80,000 tweets to train these networks. So we used 2 different networks. The first one detects what a transit tweet looks like. So we just run in a random feed of tweets, and it will tell us, is this a transit tweet or not? And then it feeds to the next neural network, which tells us, okay, this is a transit tweet, but is it an eyewitness transit tweet or just a non-eyewitness transit tweet? And we are interested in the ones that are eyewitness tweets, describing something happening right now. We're not interested in someone saying this happened yesterday or asking a question or talking about news. We want to understand what riders are seeing right now. And we built these neural networks based on features such as sentence structure, such as terms and verb tenses. And the third component is we used nice algorithms to extract location information from these tweets. So we have we parse the text, and then we can get what is the bus stop we're talking about, or the vehicle, or the bus route, or the LRT and subway line or station, and any mentions of public places. So moving on to results, we did a run on over 750,000 tweets, and we got around random tweets, and we got around 3,765 eyewitness transit tweets. However, one of the most interesting observations is that most of these tweets do not mention an agency for action. And we think that's probably because of rider frustration and low expectations. They don't see value in telling the agency that this is going on. Or maybe they're just sharing their experience with their close Twitter circle. However, there's value in directing these tweets to an agency for action, so they can actually address what's going on board their network. And we did a similar example for Calgary Transit. We got over 4,000 tweets, and we processed them, and we got 69 eyewitness transit tweets. And what we figured out here is the potential here to improve is if you can prioritize eyewitness tweets over others to ensure faster response to time-sensitive incidents. And this slide shows an example of what we're talking about. So on the left side is a chart that shows on the x-axis the response time, so how much time it took for the agency to respond to the incident on Twitter. And on the x-axis are just categories of tweets. And the blue dots are the tweets themselves. So we see for most of the tweets, they lie at the bottom with relatively fast response time, under 5 minutes, for roughly most categories. However, there are a lot of outliers that required around an hour to respond to, or 15. We see there's near 50 minutes to respond to, and there's some over 10 minutes, which in some cases might be a lot, especially that some of these tweets are about security incidents and about COVID-19, which really warrant a quick response time. And on the right side, we see that the breakdown of response times by the eyewitness tweets with high urgency topics surprisingly had a very wide range of response times and can have the most time to respond to on Twitter. So this is just to prove that there is room to improve the response time, especially if you flag eyewitness tweets to the agency saying, hey, something might be going on here, please check it out. And this is one step further. So we took all these 4,000 tweets that mention Calgary Transit, and we broke them down by sentiment and by category on the left side. And we see that when we're talking broad tweets that mention agency, there's a very broad distribution of topics and sentiments. It's sort of generally spread out everywhere. However, on the right side, we did the same analysis, but only for eyewitness transit tweets, so only for tweets that are sent out in the moment by riders as they're using the service, as they're saying, hey, this just happened. And we see the landscape is very different. It's first of all, it's much more negative, and we believe that when riders tweet about something happening right now in front of them, it's most likely to be a complaint. And also, it's very much focused on security and safety, which we understand that riders value most. And then the next is the next categories are travel time and ride quality, which we also believe that riders value most, especially when they're actually using the service. And jumping into the last section is, we said earlier that we are extracting location information from the text of the tweets, so we can geocode them and assign them to spatial distribution. So we can see from these two pictures is that we can understand, or we can visualize which parts of town are most interactive with the agency and might require more attention. And more interestingly, we can combine this with other analyses to understand different patterns. So which are the recurring themes at which area, and what are the recurring sentiments from each area. And on the right side is a similar distribution, but showing tweets sent out at bus stops that are complaining about travel time, or like they talk about travel time. And so we can understand, oh, there might be a common pattern with these bus stops in this area. So it's all about just giving more tools for agencies to process this raw, noisy data from Twitter to make more sense out of things. This is pretty much what we worked on over the past months within TAL. And just to give a quick conclusion, we believe that analyzing eyewitness tweets yields practical benefits for transit agencies because it acts as a virtual focus group. It can give real-time reports for incidents. It allows for insights on incident patterns, and it means better information management since we're going from noisy, unstructured data to something that is clear and structured. Additionally, we know that social semantic analysis augments existing efforts to gain early satisfaction, and this translates to better granularity that we can dive deeper into tweets. That is something that we do not get from the typical satisfaction surveys, and we can also track the growth of topics over time. And monitoring these discussions and social networks over time explains how riders will shape their opinions. And just a quick note to what the future research might look like. There's a pressing need to develop a transit-specific sentiment analysis engine, because a lot of the words that are used on Twitter, their context differs, or their sentiment understanding differs. So we need to have a specific engine for transit. Additionally, there's a pressing need to improve the accuracy of eyewitness tweet detectors. And lastly, how can we incorporate other data sources such as account information, such as previous tweets and followership, to infer which agency is being referred to in generic transit tweets. So if we get a tweet that just says, this just happened on my bus, without mentioning an agency, how can we look at this account's public information to try to infer which agency they're talking about? So this was pretty much the whole presentation. I give it back to you, Brendan.
Oh, thank you, Omar. It's very, very interesting. I have several questions, and as Yannicka indicated, if anybody has a question, please put it into the question frame. First, there is a question that sort of builds on the geographic identification. Vince asks, can we get locational data from where the person is tweeting from in the bus or at bus stop or other nearby location without identifying the individual? Would be useful for small transit systems. I guess, and that's sort of building on that question, if it's an eyewitness tweet, that means it's been directed at Calgary Transit or at the transit agency specifically. So I assume in most cases there's not an issue of privacy or identifying the individual, since they've sent the message directly to the agency. But for those other category of transit specific, where they're communicating with their group, with their Twitter colleagues or friends, there may be a privacy issue. So did you explore that, or how do you see that issue of privacy versus, having actionable information?
I can jump in, and then Dr. Shelby can chime in with more context. Just make a distinction that there's two kinds of location information. There's one that's embedded in the tweet itself, like some people publish their exact coordinates when they tweet, but this is a very small minority. And the other is just people who don't publish their location, but they say, oh, I just saw this at Union Station, and then we figure out that they're tweeting from Union Station. In both cases, we followed Twitter's conditions and guidelines and terms, which very explicitly state that you're not allowed to track people's whereabouts. So that's the first component, is just if they say we saw this at this bus or at this station, we just take that piece of information and deal with it. We don't really follow up with where they come or where they go. And also everything is anonymized. We do not tie in the tweets to an individual. We tie it into a unique ID, like an account ID that's just like a string of numbers, just so that we can see if there's like any sort of more vocal parts of the community. But essentially, we don't tie in any of the tweets or the locations to a single person.
Okay, that makes sense. Now, there's another question here from Manas. Do you have statistical data to correlate these analytical findings to improve operational decision making? He's from city, or he or she is from city of Edmonton. So it's in other words, I know this is just a pilot project, but did you find that monitoring the, processing and monitoring, processing, and communicating the tweets actually had an impact on the operational decision making.
Yeah, we did actually a comparison or comparative analysis between our Twitter analysis and rider satisfaction survey results. But that was not for Calgary, was actually for Vancouver. But using the same methods, and we found really very close correspondence between the two in terms of the ratings of the different attributes of public transit that are expressed in the rider satisfaction survey versus our Twitter analysis. So for example, we found that reliability is being talked more about and complained more about in Twitter analysis, and that was also corresponded well with the results of the rider satisfaction survey. So and we have for those interested, I can share with them a paper on that. That gives more details.
So that's interesting. I mean, a ridership survey, I assume these are intercept surveys or something of that sort.
Yeah.
They're sort of one-time things that they sort of are collecting information over time, as opposed to the tweets are, okay, this really, I did not like this right now.
And that's what we actually did. We because the survey asked for the past experience over the last 30 days. So we aggregated the Twitter data for the last 30 days without really looking day by day to compare, apple to apple.
Interesting. Sort of following up on that relationship to satisfaction surveys, is there, well, let me just ask, is there any bias? I would assume there's some bias in which customers use Twitter the most, so that it's, contrary to an intercept survey, which you can do it and structure it so that it's randomly sampled. I would suspect that the Twitters are not random, that they're biased. So I'm just curious what you think.
Yeah. Well, there's definitely bias. Well, there are two, I think, sources of bias. Number one is, the users of Twitter are obviously younger demographics, and also, people share their opinions on Twitter when usually like negative opinions.
Right.
When there's something positive, they do not necessarily, say, "Hey, I had a great experience." They won't really say that. So that's definitely something, and we recognize that. Well, on the demographics, the hope is that with time, people will, that the demographics of Twitter will also slowly will really mimic or be similar to the demographics of transit users, but this is going to take some time, obviously. The negativity bias is something really, we need to really account for that for sure. But
I guess I was actually thinking of a third kind of bias. I was thinking of a geographic one, where I guess riders in higher income, more affluent, likely to be more strong, more heavy users of social media, compared to routes which serve, seniors or minorities ethnic minorities that may not use Twitter as much. I don't know. I was just hypothesizing.
Yeah, no, absolutely. And that's actually something on our radar screen now, with the ability to sort of detect the location of at least a subset of the tweets. It can enable us to do some sort of spatial analysis and also look at, the distribution spatially of where those tweets are coming from, what kind of concerns they express, and try to layer this over also, the distribution of disadvantaged groups and so on, so that we can gain some insights into such bias as well.
Okay. Well, since I'm still waiting for some other questions from the audience there, Vince did have a comment that he really appreciates. Well, you could retell research on transit is beneficial and would encourage more research on how small transit systems could use Twitter. it probably would be easier because the number of tweets would be much more manageable than in a place like Calgary or Toronto. Yeah, and that's so to use it also for sort of operational people connecting between different buses. I had a couple other questions. What do you, well, first, I didn't quite understand the concept of team in one of your early slides. And so that was one. And then also, if in the same tweet, they mentioned both broken glass and a broken bench, is it just put in both categories, or how do you set a priority, or how do you see if one thing's more important than another? Is the lexicon have a priority in it, embedded in it? So those two clarifications.
Do you want to take this, Dr. Levy?
Yeah, go ahead, Ford.
Okay, cool. Just to talk about the team's functionality, yeah. So what we're describing is a platform that we built that should help agencies or even researchers to better analyze Twitter content of transit agencies to get insights. So it's a tool to help people get something done, and within that tool, we enabled them to have their different teams. So let's say I work at an agency and I work in the planning department. I can have a team that only focuses on analyzing tweets that pertain to my scope of work. Another team might be interested only in security incidents, so they might have their own team that looks at that specific type of tweets. So it's just helping team function.
Okay, I misunderstood. I thought it was a team somehow on the user side, not the user side, but the customer side. You're talking about teams within the agency itself, and to basically do the triage of which analytics they're mostly interested in. Okay, I got that. And the other question was, when you get a tweet that's got multiple components to it or categories of words, how does it get sorted?
Yeah, so we basically and Dr. Chalabi, you should chime in probably after. We basically we don't really prioritize in terms of the lexicon. It just extracts whatever is there. If it talks about two different things, then both get picked up, and the tweet gets categorized as those two categories. We can assign an infinite number of labels to a tweet depending on what the text is. So this is in terms of categorizing. It's if it talks about broken benches and broken glass, and these are the categories that we have, then it will go under both categories. Okay. In terms of prioritizing them, if it's an eyewitness tweet, it's just going to go up the top of the list regardless of if it's eyewitness, it goes top of the list regardless.
Yeah. Okay, yeah. Yeah, no, I see that. Amer, was there anything you wanted to add to that?
Yeah, I mean, just to add to what Omar said, in the area of rider satisfaction, we actually developed a dictionary of words or a thesaurus, lexicon based on two thesaurus, one by the TRB and one by Australia, to really populate, define a number of service quality, like with respect to travel time, reliability, maintenance, information, and so on. And for each one of those categories, we defined a number of keywords to look for. So once we find one of those keywords, we attach a label. For example, this is a tweet about travel time, or a tweet about crowding, or a tweet about maintenance or information. So yeah, one tweet could have multiple labels. And yeah.
There's a question just to clarify. So you've got these two, basically tool applications, I guess, of the same tool, or is two tools? I'm not totally sure about that, but one is sort of a analysis of archived information, data that you can sort of see patterns on customer satisfaction, so forth, and other is the incident detection. And so actually, are there two tools? One question: are they two tools or just two applications of the same tool? Is one thing, and the second one is, to build this, did you build it from scratch, or are there sort of platforms of analytics of social media that you use as a starting point?
Mm-hmm. So maybe I can take a stab at this first. So it is one platform, one big platform, and for the most part, it was built from scratch. Some of the tools, like a sentiment analysis, was we used off the shelf, although we are actually building a more transit-specific sentiment analysis or analytical tool. But for the most part, yeah, the software was built really from the ground up, from scratch. And those two use cases or applications are, part of the bigger platform.
Okay, I'm still. Oh, wait a second. Maybe there's a new question. I'm trying to. Yeah, it's a pilot project. Do you have plans to? I'm not quite sure. Disseminate it more, or beyond the other tests, the other applications or future research that Omar mentioned. Is there? Sounds like it might be a useful tool, but I'm not quite sure how it might be disseminated. Do you have any thoughts about that, Amr?
Yeah, we have a beta version now, and we will be happy if any transit agency would like to try it out. Test it out. They can do so. It's definitely on our radar screen to take it to the next level for commercialization. We will need to find a commercial partner and also some funding. So that's So the answer is yes. Yeah, it's in our plans to take it to the next level to bring it to a commercial grade product.
Okay, great. Well, I'm still sort of waiting for questions, but I'm always full of questions, so I'll throw another one out. In a large agency, I mean, most of the testing I think you did was sort of after the fact. I'm just curious about the ability to do the incident detection in real time in a large city where the volume is enormous, and first you've got to sort out whether it's the pertinent transit system or not, and then you've got to go through it has to do the semantics and sentiment analyses and so forth. I'm just sort of curious about this sort of scalability in the volume, and what happens if there's a real issue that happens where people start flooding Twitter with stuff all over the place.
Very good question.
It needs more beta testing. Sorry.
Yeah. Well, you want to take a track at it,
Sure.
Omar? Or
Sure. Yeah. I mean, I can say that we tried out two approaches. The first approach was, let's just process tweets that come mentioning an agency like at Calgary Transit, and that was, we didn't really implement this as like one big pipeline, so we don't really have visibility on the practicalities of where the pinch points are and where the
limitations. Yeah.
But basically, for that we did not have any major difficulties, because the flow of incoming tweets that mention agency is pretty steady. It follows a nice pattern of ups and downs during peak hours, but it's pretty much steady. The one that broke our laptops without even trying to put the whole pipeline thing was just getting like a global feed of tweets from an area, or just a global tweet feed from everywhere. So I don't really have an answer on how the software applicability of this as one big pipeline, but based on what we saw when we were doing this research, at least trying it out for one agency mentions that seems pretty reasonable. Doing it for a citywide thing is going to be a bit more challenging, because we need more expertise on how to pre-filter things and what goes in, what goes.
Yeah. No, that's fair enough. I can see how that would be quite challenging. Okay. Yeah. I think most of my questions. Yeah. So yeah, the real time training, the transit tweet in real time is could be pretty challenging. Yeah. Yeah, and you can localize the if the transit agency isn't specifically mentioned, you can narrow it down geographically if they haven't done so themselves, or not really.
Yeah, we've been developing this location detection capability. If there are some tips in the tweet itself, in the content of the tweet, about like a route number or a landmark name, so we search for those, and to our best ability, we try to match this with a particular system. But if there are no really hints or tips in the tweet, and there's no mention, then it becomes really hard.
Okay. I'm sorry. Yannicka, I'm having a little problem with opening up the question pane.
Okay, so
there was a new one, and I've lost it somehow.
Wendy is wondering, could you derive global area based on tweets that does mention agency?
All right, that does or doesn't?
That does mention agency, and then she writes, I suppose a unique agency name might make the agency method easier.
So I'll just I'll just try to stop here. I can speak of the possibility of even not having an agency mentioned. That is difficult, but we did a proof of concept. I'd say that if we go beyond the tweet, if someone says my bus just broke down and that's all they said, there is more information beyond the tweet that we can look into and try to see where they're coming from. So if someone mentions their public location in their Twitter bio, we can assign that to the largest agency there. I said lives in Toronto, then that might be a TTC tweet. If I don't have that, but I follow everything to do with Toronto, then that also might mean I live in Toronto, and that might be a TTC tweet. There's plenty of room to infer that. I'm not sure. I think, Dr. Shalaby, if you can take the second part of Wendy's question, which is
Can you repeat the question, please, Yannicka?
I guess, could you derive global area based on tweets does mention the agency? And then I think there is like another thing, for example, TTC versus Calgary. So in Toronto, we have the Toronto Transit Commission, right? TTC. Yeah. I don't know what the name of the transit agency is in Calgary. Go ahead.
To be honest, the question is not very clear to me, but I think if it's a question about really identifying which system the tweet is really referring to, yeah, it's either by if the mention is there, then that's one method. If not, then yeah, we try our best from the metadata or any hints really or tips in the tweet content itself to.
I think it also by using the metadata or what Omar was referring to, I think that's where it becomes probably more pertinent for the archived analysis. You can use that data to put it into the file for analysis of problems, even if it wasn't directed specifically at the agency. It's hard to conceive how it could be really used for incident detection, though.
And then our good friend Carol writes or asks, do you also look for specific hashtag, what do you call it?
Hashtag labels. Yeah.
Hashtag labels in the tweets and use them for part of your analysis?
We've done that, Omar, in our analysis. We've included hashtags as well. So yeah, it gets into the analysis of both rider satisfaction as well as the incident reporting.
Thank you. And then Manus asks, your proposed beta version, does it provide the metadata tags for data mapping with the bus and rail business applications to extract data, then to analyze against Twitter feeds? And can an agency get the pilot version to try it out?
Well, at this point, yeah, I mean, we can provide some sample data to show really how the platform would work. And that's really what we can provide, in addition to some description of how the different tools can be.
What I would suggest is anybody who's got a specific interest in sort of pursuing discussions about the beta platform, that they get in touch with Amr directly and just send them shoot them an email, and then you can pick it up from there with these detailed technical methodological issues and possible beta tests. Amr, I'm going to try to put your email in here. It's Amr at ECF. Sorry.
Sure, yeah, Amr at ecf.utoronto.ca.
Toronto.ca.
I can also share that in an email to all, because I have access to lots of information. I can also share that contact details after the webinar is over to everybody.
Okay, I think I got it right. These windows are very small, so it's a little hard.
Yes, yeah. So I don't see any other questions.
No, and we're coming up to the end, so I would really like to thank Amr and Omar. It's a very interesting project, and also I think it's very useful for people to know about TAL and the wide range of topics they're researching and looking at, and trying to look for more applied, look to pursue more applied research that would be of more direct benefit to the industry as opposed to most academic research. So with that, Yannicka, is there anything else I should mention?
I would like to thank you, Brendan, for bringing this webinar to our attention. Thanks again for everybody, all attendees who attended. The webinar recording will be featured on the ITS Canada website tomorrow. You'll get an email from me with those details. Don't forget, ITS Canada Virtual Conference, June 21st, 22nd. The program probably will be up tomorrow, so we welcome your submissions and your stories. Thanks to all. Stay safe and have a great rest of your afternoon.
Thank you.
Thank you.
Thank you all. Okay.
Thank you all.
Bye.
Bye.